Okay, animation is over, so I think I can start. Hi everyone, thanks for tuning in to .NET Track on the 4Developers conference. I'm Paweł, and I have been software developer for several years. And I'm here today to tell you about a few well-known parts of .NET ecosystem, which have some not so well-known quirks. .NET environment is a powerful and flexible platform with many mechanisms, paradigms that can greatly improve in productivity. And current release cycle gives us tons of new features every year, more than ever and faster than ever. Only last update of C# to version 10 gave us about 14 new changes. But there are still a lot of things most of us don't understand perfectly right. I have collected a bunch of little things that we understand in 99%, which is perfectly fine for our daily job. But there is still that 1% that doesn't work exactly as we expected. More experienced programmers may be familiar with most of those cases I mentioned today, but I believe that even they will learn something new today. But this talk is mostly aimed to junior or medium developers. Before I start, I need to warn you. Almost everything mentioned in this talk is something I was asked about during technical interviews. And interviewers often are not aware of those 1% of cases. So if you answer according to what you learned today, the recruiter may take it as a mistake. So I strongly advise to be a bit more elaborative in your answers. So firstly, let's talk about the data types. In .NET, we have two groups of data types, value types and reference types. And what is major difference between them? Value types are stored on stack and the reference types are stored on managed heap. This would be your answer, and it would be mostly considered true. But in fact, it is not entirely true. Second part is okay. Reference types like object, string, dynamic, or classes are stored on heap. But the first part is a bit more complicated. For instance, if a variable is declared in a method, if a value variable is declared in a method, it would be allocated on stack. This is easy. If a variable will be declared as parameter of method, will also be placed on stack. If a value variable will be declared as member of class, it will be allocated on heap, since class is reference object and is allocated on heap. And in case when variable is declared as member of struct, it may be allocated on stack, on heap, depending on where whole struct will be allocated, since struct is value type and can be allocated on both stack or heap, depending on earlier mentioned cases. And there is also still boxing and unboxing when we talk about value and reference type. And there are probably some more cases I have never encountered. So the next time, if someone asks you where value types are stored in .NET ecosystem, you could say that they are stored on heap or on stack, depending on the context. Let's move to the next case, but stay within typing. In .NET, we have two ways of typing. Mostly used static typing and dynamic typing. Quite often, I hear from young developers that dynamic typing is done using var keyword, which is absolutely wrong. Var keyword was introduced in C#3, and it's still a statically typed variable. In other words, the data type of these variables are resolved in compile time. This is done based on the type of value that these variables are initialized with. You cannot use var keyword without initialization of variable. True dynamic typing means that their type is inferred at runtime. This is done with the dynamic keyword. It is one of keywords I have never used in production code, but it's still quite old. It was introduced in C#4 almost 12 years ago. And let's move to specific types like lists. Probably most common list type used in .NET is generic list of T. Those who survive at least 1 year of computer science study should know how linked lists work. Linked list is collection composed of elements. Each element have data and 1 or 2 pointers to other elements, depending if it's a single or double linked list. The result of this data structure is fast adding and removing elements. But surprisingly, this is not how list of T works in .NET. Below neat interfaces and other stuff, our list is implemented using underlying array of generic elements. The name of list of T is misleading because earlier non-generic version have a better name of array list. And in the F#, other version of list is aliased as resize array. So it allows us to avoid confusion. And needless to say that the performance characteristic of operation on array and linked list is really different, especially because default capacity of list is only 4. So almost in every use case, you encountered additional allocation and need to resize those underlying array. Next topic for today is checking if collection is empty. And empty collection is not null, but have 0 elements. Most common advice is to check if result of any method is equal false. We can also count elements, but this is usually slower, because any method check if at least 1 element of collection exists, and count method iterates through all elements in our collection. But some collections offer count as property, not a method. And this is even faster than using any. Because any is linking method, which needs to go through get iterator method and then use move next to see if there is at least 1 element on the list, while count as property does simply read from existing property. The problem is that count property is not always directly available. Structures like list, iList, iCollection expose those property, but IEnumerable interface don't. So sometimes it would be a good idea to check what is the real type of our collection and to check if we can do casting to get access to those properties a bit faster. Another subject for today is null checking. Up to C#6, we had only one option: simple compare using 2 equal strings, 2 equal signs. But the problem with that approach is that 2 equal signs together make equality operator, and operators in C# can be overloaded. So you can write operator that will always return true, return false. Or if you don't like your coworkers, like really don't like your coworkers, you can create operator that will return random value. And in practice, this becomes even more evil because all code assisting tools I used to do not care about overridden operator. So let's take a look at this example. We create a new object and check 10 times in a loop if this object is null. We have our overridden operator, which grants that this result of this checking will be random. And Visual Studio or ReSharper or any other code assisting tool tells us that this expression is always false because this object was assigned a few lines earlier. But when we run this code, we see that results are random because of this operator that was absolutely ignored by ReSharper, Visual Studio, and all other code assisting tools. Luckily, since C#7, there is another way to check a null, which cannot be to check null, which is null operator, and this way cannot be modified. Let's move to another empty collection, but this time it will be collection of characters, so basically empty string. A most common way to declare empty string is using double quotes or use string.empty. And I hear quite often that double quotes are a better choice. Certainly, it is faster to type 2 characters than to type string.empty. But let's take a look about other differences. When we look at generated IL code of these 2 approaches, we see difference. Because string empty is done with LD-SFLD operation, which simply pushes value of field to the stack, and double quotes is done using LD-STR, which push string object for the literal string to the stack. So at the level of intermediate language, there is a bit difference between both approaches. But when we dig a bit deeper into JIT code, both approaches turned out to be the same. Because behind the scenes, empty string.empty works exactly same as double quotes. Both will give you the pointer to the same interned value. You see, both operations are using moving value from the same address in memory. It's mostly just a style matter of your choosing it's not about performance if you choose string.empty or double quotes. The most important is that double quote is constant and string empty is a static read-only field. So you cannot use string empty in every case, for instance, as a default parameter and switch statements or as an attribute value. So we may say that double quotes are a bit more useful, but they are not more performant. While we are talking about string, let's take a look at string empty checking. We can do it long way by checking if string is not null and then if string contains at least 1 character, or we can do it a bit easier with isNull or empty method, which does pretty same job. But is this check enough? Should we allow users to use white spaces in the form fields? Is it reasonable to perform search on database looking for only white spaces? Because if we check using string isNull or empty, we allow user to simply hijack our data validation simply by using some kind of white characters. And in my opinion, there is one more method for checking string that is way more useful that using string isNull or empty. And this new method is called isNull or whitespace. This method has a bit confusing name because it checks if string is not null, not empty, which is not mentioned in the name of this method, and also check if string is not composed with only white spaces. And based on my experience, isNull or empty almost everyone can or even should be replaced with isNull or whitespace. This is something you should check based on your domain. But in most cases, I think it's better to not allow user to flood your database with empty characters, to perform database queries for empty characters only search, or simply allow user to put white spaces in the fields when we expect them to put some more meaningful information. And while we are near string, let's dig a bit more into strings about how they work. What is the most efficient way to join strings? Most of you will answer, we can do it using string builder, because strings are immutable and string builder allows us to avoid unnecessary memory allocation, which sounds reasonable because joining strings using other operators will cause another memory allocation and creating new string. But is this always true? Is always string builder faster than other method of string joining? Let's examine 3 cases. Joining 3 strings, joining in what operation, joining 3 strings in a 3 separate add operation, and with using a string builder. We have 3 exactly same string in each case, so we expect to get exactly same result after this join operation. But when we run a benchmark, it turns out that string builder is twice slower than simply adding use plus operator, and it also allocates a bit more memory. What about the same scenario, but using a bit longer strings? In the previous case, we have only a few signs. Now we have 3 strings, each length at least 20 or maybe even 30 characters. In this case, string builder is still slowest, and the difference between other options is much bigger. Now string builder is at about 4 or 5, 6 slower than the simple string add operation. And it also allocates way more memory. So let's try to make this case a bit more faster and improve it with setting explicit value for initial size of string builder. Since we see that those 3 strings are quite long, then I think that they all should fit in 100 characters. Now, string builder result is in the middle. It's because by default, string builder allocates array of 32 characters and our string were longer. So basically, performance of joining strings depends on number of operation, string lengths, string builder length sent is in constructor. And I didn't do a lot of research about this, which approach is faster in which scenario. But as a rule of thumb, you can assume that for joining less than 4 short strings, you don't really need to bother about using string builder, because simple adding string using plus operator will do almost same with almost same performance, but even can be done better. But of course, if you don't know, you cannot predict how many strings will be joined and how long they will be, then the string builder will be more efficient operation in most cases. Next topic for today is emergency handling. In .NET is done a similar way like in many other languages, because we have this construction of try, catch, finally. A try block will be executed until the first exception. When or if exception is thrown, then the catch block will fire. And eventually, it will be run code from final block, no matter if exception was thrown or was not thrown. Sounds easy. So we basically may assume that code from try case can be done entirely or not, depending if exception was thrown or not. Code from catch will run when exception will be thrown, and finally will run always. And this is not true. At least this last part about the code from finally, which will run true. Because it's possible to write code that will fail so much, so fast and so hard that the finally code will not happen. And send catch also won't happen. And we don't need any advanced technique like unsafe code, pointers. We don't need any new shiny API. We can use just this bad boy, environment.failFast, with some necessary string which will be used as our exception message. This whale fails so fast and hard like nothing else, and it cannot be stopped. It simply blows up your application and you cannot do anything about it. And it's really old method dated back to .NET Framework 2.0. So it was available for about 20 years, but most of us didn't need to use that. Well, probably in most cases, you really don't need to care and to be aware that this exists. But in a few of my projects, we encounter code that using this was justified. And if you don't know about this, how it works, it's really interesting when you see that your application blows up and finally is not called. So when someone asks you during technical interview if code in finally statement will execute always, you can say with confidence that you can provide example when this code from finally will not be called. Let's go back to a bit more useful stuff like class properties. In C# we have at least 3 common ways to create property. Old way with explicit backing field and property, common way with auto property, and a bit newer way with expression body member with this fancy lambda arrows. First way is straightforward, so I will skip it. And the auto properties and expression body members become more interesting when we use them in read-only scenario. They both seem to work the same way, at least in this example, when we just return int value. But when we change return type into greet, then we can see a bit odd behavior. Because the first approach using auto property will return the same result on every read after the first one. And second approach will return different result on every access. The first approach is easy to explain because auto properties are just syntax trigger. There is still backing field behind the curtain. So in this scenario, this field will be right once, and then we will only get the ability to access this data. Expression body members works a bit different. In reality, expression body member is just a method that will be executed on every case, on every access. Sometimes this may be a meaningful difference, especially in scenarios like returning greets, date time, or maybe working with strings, when every access may cause additional memory allocation and creating string. So remember that expression body member may not have this bracket that inform us that this is method call, but in reality behind this we will just call method that will do the same operation on every access. Next case is not about .NET itself, but it's more about .NET ecosystem. But I like it so much, so I had to include it. Imagine a simple and common case. We have a collection of elements, and we want to filter this collection and count the number of elements after filter operation. We would probably do this similar way like this. We will create we will use link queue, where method with predicate, with information how this filter should work, and then after where we would call the count method to get information about the number of result. And when we use that approach, we'll get information from our coding assistance tools that we can replace this whole part of code with just single call to count with the same predicate, which is here placed in where. So we end up with probably something like that. At the top, the approach that we used first, and in the bottom approach which we used after listening suggestion of our tools. And when we test both versions, second ones turned to be at least 5 times slower. So basically, we trade 7 characters of source code for 5 times longer execution. And in my opinion, it's not the best deal ever. The reason of this difference in performance is that count with predicate and count without predicate are 2 entirely different methods. Let's take a look at them closer. Count with predicate does 2 null checks and then iterate through all elements. So we had a case mentioned earlier that we need to iterate through all elements to count the number of them. While count without predicate does 1 null check and then 3 casting attempts, looking if there is an underlying collection with count property. If this property is available, then the value is returned immediately, and only when there is no access to this property, this method will go and iterate through all collection element. And this is one of the reasons why you should be at least sometimes a bit suspicious about coding tools and their suggestions. And this problem occurs not only with LinkU, sometimes with these new shiny tools like pattern magic. Tools like ReSharper can advise you to use a bit different approach, which works fine in the most common cases. But when you dip a bit deeper, it turns out that also can have some side effect or work a bit differently on edge cases. And another topic for today are regular expressions. Regexes in every language and every technology are incredibly powerful mechanism, and they are so incredibly powerful that gave us countless opportunities to shoot ourselves in the foot. And here I will mention the most common way in a .NET ecosystem. Because during technical interviews, I was asked many times how to make regex like this faster. This is quite a simple regex, so there are not so many opportunities to improve it. So obvious answer is to use this regex as compiled. So we make code like this, add option regex options.compiled. And when we run test over these both approaches, turns out that compiled version is more than 200 times slower. It is because in this case, when we use regex compilation, compilation will happen on every method call. So we force our JIT compiler to do a lot more work. The intention of us as developers were quite good, but execution utterly wrong. To make proper use of this compiled regex, we should put it into static content to make sure that this compilation will occur only once, or at least way more frequent than on, like on this example, is on every method call. Last case for today are interfaces. And probably everyone had to answer this question during technical interview. What is the difference between interface and abstract class? And one of those differences was that abstract classes can have implementations and interfaces don't. Of course, this is not true today, because in the C#8 we got this default implementation feature. And surprisingly, it was not true in C# for at least 15 years. Because in C#3, in 2007, we got extension methods. And extension methods works not only with classes, but also with interfaces. So basically, you can write code like this, and it works like a charm. You can have default implementation of interface, even of method of interface, not with even without using this C#8 feature. But in my opinion, is feature nobody asked for and nobody really needed. So I'm really glad that not many people know about this presence. And this is all I got for today. Hopefully you find this interesting and informative. Thanks for watching. And now we are going back to studio.